All right, so welcome everybody. My name is Ben Pomerenke. Today I'm going to talk about Terraform. So just a little bit of background about me. So I've been in the industry for about 15 years. Started off in flight simulators, worked through project-based consulting doing C# at first, some web application development, and I really kind of got into AWS and just any cloud development about 9 years ago. So pretty early in the cloud provider story. And my first experience with it was using Terraform. It was a relatively new tool at the time, but the team that I had kind of taken the work over from thought it was the right answer, and so I had no choice. I had to learn it, had to figure out what was going on. On and off worked on AWS projects for a couple of years. Finally landed on an Azure project, knowing very little, if anything, about Azure, but it was an Azure project that was leveraging Terraform. So because I knew how to do Terraform, I was not completely lost, and realized that conceptually Azure and AWS are effectively the same thing if you know the right terms for the right products. So through all that experience, I was mostly doing project-based consulting until about 3 months ago, in which I formed a new company to develop software products for the warehousing logistic industry. So the technology platform that we have chosen is AWS. So one of the compelling aspects about our products will be that they are cloud-based, although it's not as compelling as it may have been 5 years ago. But we are going to build SaaS products. So the idea is we want to have the flexibility that a cloud provider provides us. We are using Terraform. So I have been steeped in Terraform for the past 3 months. I actually gave a version of this topic to the engineering team that I don't work directly with, but is kind of adjacent to me at my new company. So why would you use infrastructure as code? So Terraform is what's called an infrastructure as code tool. Basically, infrastructure as code is a way of quantifying the resources that are out in the cloud or on a server in a code format. So all the things you can do in code, you can do with your infrastructure. Things like keeping it dry, so not repeating yourself, creating blocks of code that are reusable, so reusable chunks of code, which is really nice. You can also do logic inside of it. So you can say, if this resource is in this, say, region in AWS, maybe I do something a little bit different than I would do in another region. And so having those abilities is just really powerful. Like when I first played with AWS, I would say this was 10 or 12 years ago. It was like right when it came out, I was like, oh, what's this AWS thing? What's cloud computing? And I got lost in the screens of the console. Clicking around, if you've ever used AWS, and I'll show you it in a little bit, it's a massive UI. Like they have a service for everything. It's hard to even know what you're looking for. And that my first experience was very much that. It was like, I don't even know what's going on here. But when I finally looked at it through the lens of like an infrastructure as code tool like Terraform, it all started to glue together. So as 6 or 7 years of programming experience, I was used to connecting dots in the code, not so good at looking at a cloud service provider. So that was very nice for me. So that's kind of what sparked it. And so other things you can do, which is really powerful with infrastructure as code, is you can actually replicate your environments. So you can confidently say they are the same. So one thing that happens in software development is you want to have like a lower level environment where you can break stuff. Everybody has like open permissions to everything. You can break stuff, you can try stuff. And that's where you develop most of your code because that's the safe space, it's not real data. You can always delete something accidentally and bring it back. But the problem is when you develop in that space and then you move to another environment, so you promote your code to another environment, you sometimes have to deal with differences in environment. And those differences can actually lead to extremely costly debugging sessions. And the closer you get to production, so usually there's a couple different levels. There's dev, test, prod is kind of the classic setup. Every step to production, you get a little bit more realistic. And you get a little bit less access to the system. Think if it's medical record system, you don't actually ever get access to real medical records as a developer. But you have to be confident that what you're writing and the environment you're working in is like that environment. So infrastructure as code is a great way to create that parity, to be confident in that parity, honestly. You can create the parity a lot of different ways, but the confidence of just saying, well, that's the code and it says it's exactly like this environment, that confidence is great. One of the things that's nice about it is it gives you like a quick way of incrementally modifying your infrastructure. So a lot of cloud resources are interdependent, and it's really kind of, sometimes it's hard to know like what the dependencies are to do. Like let's say you want to set up a database, right? Well, it turns out to have a database that you can connect to from a server cluster, like a ECS cluster, that database has to be distributed across two availability zones. It has to have, its network has to be connected through the same network as the ECS cluster, and that ECS cluster has to have actual like permissions, egress permissions to actually get to the database. So there's a lot of interconnectedness there. With infrastructure as code, you can kind of trial and error it. You can say, oh, what happens if I add this part of the equation? See what happens. And it usually will tell you, oh, you're missing the other thing. And you can kind of iteratively do it. Whereas if you go through like the console, actually a lot of times in the console it does it all magically for you. You don't even know what's happening, which is actually kind of scary for a different reason. And so, so having that ability to like methodically build out your infrastructure is something I really like about infrastructure as code. And then lastly, the ephemeral environment. So a lot of times you'll want to have, so a lot of cloud providers are actually pay per time or pay per compute. So you don't necessarily want your stuff up all the time. We had a team one time that I want to say our compute was costing us, I think it was like $50 a day for our dev environments. And we ended up turning on there's like a tool you can do that says to basically turn them off at night, and it went down to like $10 a day. Right? So like that's a perfect example of, well, for a minute a day, if I just push a button to turn it on and it just all comes up automatically, I can save myself $50 a day. Like a minute's worth $50. There's a point where it gets to be not worth it, but there's some real benefits to being able to stand up an environment just on a button click or a command run. An entirely new environment that's fresh, doesn't have any kind of historical data, nothing wrong with it. It doesn't have the artifacts from me tweaking around with the stuff in the console the day before. So that's really powerful too. So infrastructure code lets you do that.
Do you get into anything about idempotent operations and how that is useful in infrastructure as code? So you can basically replay the same set of instructions, but you only ever get this one outcome?
No, but that's I'll add that for the next time I present. Yeah. So what he's describing is like, even if you've already applied something, you can always safely reapply it. So like you never have to like second guess yourself. Well, do I run it again? Like, is it going to break if I run it a second time? And I do that a lot actually. Like, I can't remember what I did 5 minutes ago. I'm going to do it again because like it takes 2 seconds to do it again, and I know it's going to result in the same outcome.
What were you using whenever you had that switch you turned off? Was that like that? It sounds familiar to one of the things that I was learning about last semester. Was it like Lambda, or was that
You're talking about the thing that would turn the thing off at night?
Yeah.
I think it was called guard duty. No. It might have. It was something that alluded to like paying attention to your stuff for you. I can't remember what it was called though. That was like 8 years ago, so it's been a while. No, it's a third-party product. You tied it to your AWS account, and it would watch you could set schedules for when to turn your instances off, and it would. Okay, that's not it. No, it's a third-party tool. It could have been like Datadog. No, Datadog doesn't do that. That's a log. I don't know. Ephemeral environments are a better way to do it. It gives the control to us. So when I say push a button in that situation, what I'm talking about is like our pipeline tool. You could run a step in a pipeline that would stand the environment back up. And so you push a button, you go get your coffee, and when you're back, the environment's stood up.
So like if you were comparing it to just like a standard website, basically the website wouldn't be running until you came in and turned it on.
Yep.
What's nice is you can make your own copy of the environment to screw around in and not mess with anybody else. Great feature.
Yeah, so teams that have like competing resources for what they're working on, like this group of team members is working on one thing that's destructive to the other team, you can just separate them out. Yeah. So, yeah, think of it like a 3D printer, right? So infrastructure as code is like the 3D model you feed to a 3D printer, and at the end you have a physical object that
It's a
is
blueprint and everyone gets their own when they
Yeah.
launch it. Okay.
yeah. All right, so there are a lot of I should have called this out. I kind of meant to. There's a lot of IAC tools out there, and I'll talk about the variations later on. So, why would you want to use Terraform specifically? So, I had it easy. I walked in, and that was the first thing in front of me, and I like shiny things, and I learned it, and I was like, that's all I ever need. But over the years, I've had to kind of debate it with people, like, do we use Terraform or do we use something else? And kind of where I've come to think about it is there's really three main benefits of it. So number one, it is cloud provider agnostic. So if you are hosting on AWS now and you'll always be on AWS, and you know that for a fact, that's awesome. You might not need to use Terraform. If you know that AWS can give you everything you'll ever need, and you'll never want to use something from Google or Cloudflare or whatever, you can go with the AWS variant. But Terraform lets you actually mix and match the cloud providers together. So the way it's designed doesn't let you reuse code for each provider. Like, they are very specific definitions of resources in each provider, but you can actually wire together the information from one provider to another. So like maybe you have your database in AWS because they have a really good cloud-based database you like, and it's talked to from a compute instance in Azure because you write .NET code, you migrate all your code to .NET, but the Azure databases are too expensive. You could actually use Terraform to create both of those resource sets and then patch them together with like a trust relationship. I have never done that myself, but in theory, it's possible. Working in a project-based consulting company, it was very important that we had a cloud-agnostic tool because we didn't get to determine what our customers used. So that's actually why we used it a lot at WWT. It's just I like to use it still. And then part of that agnostic aspect is the Terraform docs themselves are actually a great learning resource. So I mentioned I did Azure for the first time 3 years ago. I knew nothing about Azure, but I know how to read Terraform docs. And I think I was brought on as an architect because I was like the adult in the room, not because I knew how to do anything on the team. But like within 6 to 8 weeks, like I was the delivery engineer, which is like the infrastructure guy, and the infrastructure architect, because I actually knew more than a lot of our Azure experts, and it's because I knew how to read the Terraform docs. I knew how to navigate through the code, it's super powerful. Even today, and we're starting our company, there's technologies I've never used before in AWS. So like I had a very tight experience, and the products we're building now are using a lot of those 50 million other services that I've never touched before, and actually Terraform is how I've gone through and understood them. So it's nice that way too. The other thing is it's kind of the way it's designed, it's inverted. So Terraform doesn't actually interact with the cloud providers. It delegates that responsibility to what are called provider. They're kind of like packages, and they define their contract, and Terraform just orchestrates them. So Terraform doesn't actually talk to any of the cloud providers. So somebody the other day was like, Terraform got hacked. Are you worried? It's like, I don't know how they got. Maybe if they injected some like bad code into their source code, I'd be worried. But like, very likely what happened is Terraform provides a service that probably got hacked, and I don't use that service. I just use the free tool. So because of that, because they've inverted it, what that allows is all of the support for the cloud service providers is it moves as fast as the cloud providers or the communities around those cloud providers want them to. So a new service comes out on AWS. Within maybe a couple weeks or months after AWS supports it, like via CloudFormation, it'll be in Terraform. And it's because Terraform doesn't actually control those interaction points. That's a third-party kind of module that you can choose to use or not use. So that's pretty cool. And then lastly, it's very lightweight. Like, I think the Terraform executable is like maybe a meg. I don't think it's even that. If you're on a Windows machine, it's literally an executable file. That's all it is. Actually, that's all it is on a Mac too, but it's like a single file. There's not a lot of dependencies. It actually is smart enough to pull its dependencies down at runtime. So it's super easy to download. It's super easy to manage the version of, and I like it for that reason too. All right, so I've talked about like why you should use Terraform, why you should use IC. So I did want to show kind of an idea of what it's doing. And this one I'm going to probably point at the screen because the mouse doesn't usually do a good job of showing it. So in general, what Terraform is doing is it is diffing a blueprint, like kind of what you said, of what's out there. So on your machine, you have a blueprint, that's the Terraform files. And then out in a cloud provider, or you can put it in Terraform Cloud, which is their managed service, or you can put it on your disk. You can put it wherever you want. There's this other copy that is the actual manifest of what's out there. And so all Terraform is doing is taking those two things and saying, what's different? And based on what's different, it's going to go create or destroy resources out in the environment. Okay? It's a little smarter than what I just described, but that's the gist of what's happening. You have what do you want? You have what's actually out there, and it diffs the two and decides what to do. Do you have a question? I'm going to show you how this. I'm going to show you this happening in a second.
Or does it?
So you don't have to. You worry. All you care about when you're developing Terraform is what do you want the end state to be. So I, as the developer, say I should have an S3 bucket. I should have an EC2 instance. You know, maybe the EC2 instance has access to the S3 bucket, like the permissions. You say, this is what I want AWS to look like. That's what you write in the Terraform. And then you tell Terraform to do the diff and apply it.
And then it decides what to retain or get rid of based on the criteria you provided it at the beginning.
Yep. Yeah. Yep. And so that's why, I mentioned earlier that environment parity, if every environment is running from the same blueprint, if it's different, that state will actually say it's different because that's a manifest of what's out there. And then Terraform will update it to be the same. And so after an apply, which I'll show you in a second, but after you apply the changes, and it's idempotent, you can keep running it. It says there's nothing more to do. So the code itself looks kind of like this, where you have a resource, or there's actually another kind of element called the data. But this is kind of like, hey, this is a variable. You have the type. So in this case, it's an Azure M resource group. That's a Azure resource. And then the last thing is your actual variable name. So in this case, it's example. And so this you can think of as logically a variable in your code. Okay? There's some variables that are editable, like you can change them. They can cause changes out in the environment. There's some resources that are read-only. So this is a editable resource. The data element is actually a read-only. So you can actually suck data out of the environment if you need it for other reasons. Okay? And then each one will have kind of a property set. And that property set, where I mentioned I use Terraform Docs to see what I can do, that property set is whatever that provider has defined can be set. Okay? So sometimes there will be differences between what the provider supports and what's truly supported out there. They only last for weeks or months. They don't last forever. And honestly, if you're on that bleeding edge of the cloud, I don't know. You might want to second guess doing that for a production environment, anyways. But for most systems, you're not building in that space. And so that's how you define it in the code, and I'll show you it in a second. And then in the state, it's actually it's the same conceptual data as it exists in the environment gets written out to the state file. Okay. So one thing that you'll notice in this diagram, what Terraform is not doing, and this is something you got to be careful about, is if somebody goes out to this environment and creates a bunch of resources that Terraform never knew about, it's not going to know what to do with those. It's not going to think they even exist. Now, it may try to create one that's called the same thing and get a conflict, and it'll tell you that. But unless Terraform knows about it in that state file, it might as well not exist. Okay? And so that's why actually protecting that state is actually super important. In fact, a lot of times, like, well, I haven't done it yet on our products yet, but a lot of times that state file will live outside of the environment you're touching because you wouldn't want somebody to accidentally delete it or modify it. Terraform actually provides a third-party service that'll maintain that state for you as well, which is pretty awesome too. So they have a lot of niceties around it too. So that's the gist of how the tool works. Any questions? It's like stupidly simple, but it's super powerful at the same time. There is a link at the bottom. I did not come up with this on my own. Credit this to itnext.io. I thought this one just showed the visualization really well. All right, so I mentioned kind of stupidly simple. This is what it takes to run it. So there's like 4 main commands. There's some more advanced commands that I'm not going to talk about tonight, but so Terraform init, that is where you basically said, you say, I am going to build these kinds of resources. So what providers do I need? So it's smart enough, and it goes through all your Terraform files and detects what providers you'll need. And then it also wires up to that backend. Make sure it knows where the backend is. It might do some like data transfer. I don't really know exactly what it does. But that's basically like your initialized, you're about to do some Terraform. Once you've initialized it, you kind of have 2 options. You can do a plan or an apply. They both actually do the same thing for the first step. So an apply actually will do a plan as well. But the plan is like, it's only going to show you what's going to change. So it says, based on this blueprint, based on what the manifest says, these would be the resources I'm going to create. And so that's a lot of times really good for like making sure you're not about to blow up something. A lot of times we'll incorporate plans into the build pipeline. So yeah, we're going to roll out this change to the lower environment dev, but before we do that and do more work around it, we're going to make sure it's going to work in the higher environment. So we'll do a plan against the higher environments and we'll apply it to the lower environment. And you can do like approval steps where people read that plan and make sure it's good. Apply will actually cause the changes to happen. It will prompt you if you just run it by itself. You can actually say like force apply if you want to put it in like a pipeline or something. So typically I will always do an apply with a force apply on like a pristine environment so that I can prove that it doesn't blow up. Because there are some things that plan won't catch. So when it starts to actually apply the changes, it can actually run into conflicts or things that are out in the environment that it couldn't detect. And so I always like to do an apply against at least one environment. I usually call it like the CI environment to prove that it's going to work before I promote it to other environments. And then lastly, Terraform destroy. It basically says take everything that you know about in the manifest and delete it. This is really powerful with these ephemeral environments. If you want to be confident, you tore everything down. It gives you that confidence. One thing that I always hate about cloud environments, so I've been in AWS a lot of my career. AWS is a lot like Amazon.com. They make it super easy to spend money. And so like they will let you rack up a $10,000 bill on hardware you never use, because that's your responsibility as the user of their account. And so one thing I really like to do, especially with like prototype projects, if I do them in Terraform, when I'm done, I can just say tear it down, and I'm confident it got everything. So that's also a nice thing. So you do have to be careful though. Like you want to make sure like everybody doesn't have the ability to destroy your prod environment. So you got to be a little bit careful. Like it's kind of scary what it can do, but it does prompt you and make sure you're sure you want to destroy everything and shows you what it's going to destroy. So.
But it has the ability to initiate certain permissions. Like you can make it so that not everyone has the ability to destroy, right?
Yeah, and that permissioning model really comes from how you configure the cloud provider. Okay. And so a lot of cloud providers, so a big difference between cloud providers and like, say like a physical computer or server, they take every concept that you can do in a typical operating system and they like dissect it out into like a bunch of different separate services. And one of the nice things about that is there's all those permission boundaries that you may not have had access to when it was all one system. Yeah. You can put layers of permissions between everything. And so you can do things like saying, okay, this user can do a plan. Like this user can see what's in the state, so they can do like a plan, but they can't actually edit the state. So they can't do an apply or destroy. And that you can put in like business rules around your scripting that makes that true too, but you can actually enforce that in the cloud environment or wherever you're managing these states. And so, every system looks a little different though. So there's not like one size fits all. But because of the power of this tool, and I mean, the same thing's true with apply too. Like apply can cause things to get deleted as well. If you take something out of that blueprint, it'll think it needs to delete it. And so, there's a lot of power here, but usually if you just do separation of concerns and least privilege, all that kind of stuff, usually there's ways to work around that power and be safer in a prod environment. A lot of times we'll do like jump keys, like it won't let you apply until 2 people have said yes. But there's a lot of different ways to do it. All right, so now you can see the code. I don't know how, probably going way over on time. I think we're still okay. Probably, yeah, because we started a little earlier. Okay, so let's look at the code. Hopefully I can, there we go. All right, so I mentioned earlier that the blueprint is what you look at. So this is the files that have the blueprint in it. There's no rhyme or reason to why things are called what they're called. There's no conventions in Terraform from a file naming perspective. Like Terraform doesn't care what you call them. There's a lot of different styles, though, that you'll see when working with experienced Terraform people and how they name stuff. So I will say my style is whatever works. I'm not a very opinionated style. But I always do create a main.tf because the person that taught me did that. What Terraform actually does when it runs, it actually combines all the TF files in the same folder together. And it creates what I refer to as like a scene graph. It intelligently stitches everything together and wires all the dependencies across files. Like that's one of the cool things it does. There's actually a way I think to print that graph if you want to. But it doesn't care how you structure the files, but it is very much looking for all the TF files in that folder. And then you can have like modules in subfolders, but it ignores them until you reference them. So it doesn't care about the subfolders until you say that, hey, there's Terraform code in this. And so I'm not actually going to show that today. But I talked about the 2 kinds of resources, the read-only and the editable. It's a terrible word for it, but so resources and data. But there are some initial like setup things that you have to do as well. So this Terraform block is kind of like what is true about like your instance of Terraform, or you can like definitively say like, well, I know if I don't have the AWS provider, nothing's going to work. So you can put things like required providers. You can actually specify like which version of Terraform do I expect to be running. You can put a version lock in this file to say, okay, if I have 1.13, I'm good, but if I have 1.14, don't do anything. Like, I'm not ready to upgrade yet. So you can do things like that. This is where typically the backend is defined if the backend is the same for every environment. A lot of times I will actually set up the backend as different per environment, just so that I can move things around later. There is a concept of workspaces, so one backend for every environment, and so that would be why you'd have the backend specified in this file. This example is doing a single backend, but I also am not doing ephemeral environments. I'm not going to stand up more than one version of this. And so you can specify some options. So I'm using the S3 backend. I mentioned earlier I don't use Terraform's backend, but this is where you'd say, hey, my backend's in Terraform, the Terraform Cloud, the backend service manager. But I just use S3. It's just an AWS resource that is where my manifest gets written, and that allows me to put it wherever I want. I also use a DynamoDB table for the state lock. So a state lock is when I say apply, if one of my team members is applying the same plan, or applying to the same backend, maybe it's different changes. It doesn't really matter if it's the same or different. You really don't want those 2 things to collide. So in this backend, you can actually specify a Dynamo table to put like a lock key. And so while I'm deploying, until it finishes, they will be blocked from deploying, which is really cool. And then you can specifically register AWS or configure providers. In this case, the AWS one wants to know what region I expect this to be in. So just like that, we're technically started. So I do have more code, but it's all commented out. So right now, if I do a Terraform apply, you'll see there's nothing to do. Okay, and just to prove that, just going to refresh this page. All right, so all you see right now are the config bucket and the TF state. That's how I create the state. So that's where the manifest is being stored. And so there's nothing else there in S3. If I jump over to this S3 file, I have some pre-written Terraform. So I'm just going to uncomment this. And all this is doing, so I'll talk about the variables and the locals in a second when I do the longer running resource creation, which is coming up next. But all this has is two resources, which is an AWS bucket and a bucket ACL. And it's going to create a bucket with this local prefix and the word example bucket. So I'm going to go ahead and apply that. You'll see. So it'll prompt me and say, hey, this is what I'm about to do. So it says I'm going to create a ACL and I'm going to create a S3 object. You'll notice it's doing a lot of stuff for me. I don't even know what half this stuff is. I'll be quite honest with you guys. But Terraform has defaults for all of it, so I'm just going to let it do it. Okay, so you say yes. It's hopefully not choking on the internet. Oh, it went. Okay, so it added two resources. So those resources are now there. So it's just this example bucket. Okay. So I have a few more resources I'm going to create. And I'm going to start that off. It does take a little bit longer to do this next one. So I'll come back to what this is actually doing, but I'm going to go ahead and kick it off.
How long would this take you if you just went straight through AWS to do it? Is it a lot longer?
So what I'm about to kick off is creating what's called a CDN. I did this manually because I couldn't remember what all I had to do. The whole process took me about 20 minutes, 30 minutes, I think. I actually watched, when I said I presented this to the engineering team I'm adjacent to, I watched them do a demonstration of setting up the VPN or the CDN and then watch them propagate it to multiple environments and then write all the documentation about it. I would say for their CDN, it took them about 6 hours.
Just for AWS?
If you do the whole SDLC on setting up the CDN. Once I knew what I was doing, you'll see, this is how long it takes. So I'm going to run it, but it does take about I think it takes 3 minutes because CDNs take a while. So a CDN is a cloud distribution network. This is like millions of servers all around the world, and I'm not using all of them, I'm only using the ones in the US, are all out there ready to basically repeat web content for people. And so now, as this is being created, basically it's propagating the web content that I may want to push out to people to all those servers.
Is that like availability zones?
It's like that on steroids. It's like an intelligent network of servers that are close to the browsers that are trying to load the content.
Okay.
Think about doing an update to like Call of Duty, World of Warcraft.
Sure.
CDNs and all, you get the files close to you, so it's a fast download.
Oh, okay. And I know like two things, like edge locations, availability zones.
Yeah, so CDN edge locations is a CDN concept. It's pushing the files out to the edge locations so that they're closer to the people downloading them.
Okay.
And so the wiring up of that network is not fast. So it does take a little time because just that thing takes a long time. But, I can spend, it does take, I think it takes like 2 or 3 minutes, but I can spin up 15 of them in 2 or 3 minutes because it's not stopped by my computer. It's stopped by how long it takes to do the CDN. So, what took them 6 hours, it took me about 20 minutes to 30 minutes to do the first one, not doing it right. And then it took me about 20 or 30 minutes to do the Terraform. And now I can do a CDN in 2 minutes whenever I want. They still have to read the documentation and redo it. Because I have the blueprint. Yeah. Which is another benefit of Terraform is you can kind of pick and choose things that you've done in the past and reconfigure them. Now, there's potentially some intellectual property issues there, and so I typically will always copy from Terraform Docs because that's public domain, and then I'll modify it. But like on project-based consulting, there were times where I really wanted to open up that repo I worked on 6 weeks ago and just copy over that Terraform. But I was like, nope, that was somebody else's intellectual property. I got to go back to the docs. I got to redo all of it. But you get good at it and fast at it over time. So now I own the intellectual property I'm working on right now because I own the business. So yeah, I mean, I guess I could steal my own intellectual property, but yeah. So that's still running. While that's running, I did want to kind of talk through some of the things that were going on in this S3. So you can see this right here is string interpolation. So this is where it looks a lot like code. So this local is just a local variable. So it's only accessible inside Terraform. It's not accessible outside of it. So it doesn't get written, or it's not, you can't change it from the outside. It's only in the code. And you can express that here. I use it a lot of times to prefix things so that I don't have naming conflicts with my resources. Here is what's called a variable. So they're used a lot like locals, but they can actually be influenced from the outside. So you can set a variable a couple ways. You can set it with an environment variable. So prefix anything with tf_var_ and then that variable name. It'll actually respect that environment variable when it applies to Terraform. And I'll show that in a second. You also see how you can reference resources against each other. So this is an S3 bucket, and for the ACL, I actually have to use the ID from the S3 bucket, which I didn't specify in the S3 buckets Terraform. I have to actually reference that so that I can wire it together. Okay. And then the last thing is you can actually, and I'll show this on the CDN, there's a lot of situations. I mentioned the data before. So here's an example of a data. So I know there's this caller identity is like, who am I? That's how I got the account number, which the CDN needs to know the account number for a permission. It's like right here. So this is AWS syntax, just so you know. So it's a policy document. So it has nothing to do with Terraform. But
Wired all the same.
well, so the CDN access policy,
Yeah.
the definition of that resource does require a policy. So
And if you want to get complicated, you can define a resource that is a policy and then include that in there, but
Yeah.
it's messy.
yeah, I have examples of that in our production code. I don't have it in this one. I think I went.
Easier.
Yeah. And then the last thing is you can actually output data from Terraform. So a lot of these cloud resources have you would never be able to know what their IDs are. In this case, I just created a CDN that I didn't put an actual web URL in front of. And so there's no way I'll know what that is unless I output it. So you can actually output these so you can see them. And the way those play out is like this. Okay. So just to prove it actually is a CDN, I think I have to upload a file first. Maybe I made its own bucket. No, it's this one. So I'm just gonna add a file to it. Come on. So I have a nice little index HTML. And if I go out to the web, I got a CDN, yay. And so, yeah, I'm probably going to wrap up, but there's a lot of cool things you can do. I mentioned the Terraform docs earlier. What I was going to show you is how you can just add a resource. I can probably do it here. But 90% of the Terraform docs give you everything you need. Almost every time I use it, all I have to change is the name of it. So like, and it's very easy Googling. So you say Terraform, in a Google search, you say Terraform S3 bucket permissions. And it'll find you, like, it'll give you, the top results will always be which Terraform resource are controls permissions. And so usually I'll just copy it directly here. So this is just a block public access. All I have to do is change this to be example bucket, to be my actual example bucket, and then run it again. And I should really do force apply for this, but so it's going to create another. It's going to create another resource out in AWS for me. And so a lot of times that's how I navigate this stuff. In combination from what Terraform itself tells me I need to do, or what the cloud provider tells me I need to do. Because a lot of times it'll say you can't do that. It's not going to work without X, Y, or Z. And so I kind of just iterate through it that way.
So now if you go back to the website, does it give you
So that block public access is not going to affect the website because the CDN has private access to it. So, yeah. But if you look at the actual S3 bucket, and you go to permissions, you do see that it has block public access on, which it didn't before, which, like I said,
It's more of a redundancy here, but
well,
because the CDN.
AWS gives you a lot of dials to turn, and the recommended practice is actually you turn 3 dials to turn off public access. It's actually kind of annoying. I just kind of had an argument with our cloud provider about it, like, why do they do this? But it's because of the different layer. There are situations where one dial isn't enough and the other one is. So I'm just like, you say turn all 3 dials, I'm turning all 3 dials because
Yeah,
it's a private S3 bucket. I don't want anybody else to touch it.
certain amount of manipulation might bypass one or two.
Yeah. So, and you'll see that policy that was in the Terraform showed up here with some of the things actually resolved. So, I'm going to jump back to the presentation. Just wrap up, maybe. Oh, it's full screen. So there are some things you can do that are pretty cool. So I showed off like in variables a little bit. I didn't show you how you can there's a manifest of variables called TF-vars. You can basically have one variable file that has all of your environment specific stuff in it. And then you can basically like load that in when you go to do an apply. So it's just a command line parameter. A lot of times that's nice to just send us to left-right compare environments and see what's different. And I had mine set up that way. I just didn't show you how to do it. Resource dependencies, I kind of pointed out how you can reference one resource and the other. Modules are really cool. It's basically a way of reusing chunks of code. So a great example, well, even the example I did, this S3 bucket, even though it was just a bucket, has 3 resources. Well, the only thing I care about is the developers, what's the name. So you can actually abstract everything else in the code away into a module and only have the person specify the name. There's actually third-party modules out there too that are really cool too. So you can like spin up a MongoDB database like in 2 seconds because you used a third-party module that does everything for you. So that's cool too. And then lastly, TFENV is really cool. So it's like NVM. It's a version manager for Terraform. A lot of times when you jump between code bases, it becomes important to have the right version of Terraform because good Terraform developers will lock in the version so that it's an intentional upgrade, not an accidental one. And so being able to jump around versions is super important. It's kind of painful to do it any other way. So, all right. For those of you who don't know much about IAC, there are definitely other IAC platforms. Every big cloud provider has one. So AWS is called CloudFormation. Azure is Azure Resource Manager or ARM templates. Google has one called Cloud Deployment Manager. The good thing about these is they are literally maintained by the cloud provider. It's very unlikely they ever release a service that doesn't have support. So in some cases, I've used Terraform to actually instrument these because Terraform didn't support it yet. Or Terraform supported it, but in a really weird way, so I'd rather trust AWS to do it than me. So these are really powerful. The syntax is different. Most of them are YAML or I think JSON is supported in AWS. But the syntax looks a little different. It's more like you're just putting, the manifest out there, and then it figures out what to do. I thought they were a little clunky personally, but a lot of people have done a lot of cool things with them. So, if you're going to be on a single environment for a long period of time, AWS, Azure, or Google, it's probably worth learning these instead of Terraform. If you think you might want to have that flexibility or the ability to kind of change and use that common tool, then something like Terraform is better. There's also a lot of partial ISC helper libraries. So serverless, if anybody's ever done serverless development, it requires a lot of creation of resources, and it's really hard to manage them all. I don't know anybody it would be really hard to point and click every serverless thing and wire it all up to the outside world. And so a lot of these frameworks really they're ISC tools that are meant specifically for serverless. And so serverless framework's great. I think I've used AWS SAM. I haven't done a lot of these other ones. AWS SAM is actually just a layer on top of CloudFormation templates, which is really cool. Another cool thing about a lot of these is they can be emulated locally. So if you use these, they actually have the built-in support for running it locally. And then Ansible is actually a pretty decent ISC tool. It's actually designed for configuration management. So I don't know how it does what it does. I've used it once or twice, but it's really meant to manage the server configuration. All the permissions are what we expect. Same idea as what Terraform does. It's just meant for single resource and a bunch of different things. But in order to do that, a lot of times you actually have to be able to do cloud resources. So that in the last 5-10 years, there's a lot of cloud resources available in Ansible. So if you already know Ansible, that's a great option as well. All right. That is my presentation. I'm happy to take any questions. I'm going to stop the recording, but